Good morning and welcome to this morning's webinar on design studies with a particular focus on the simulation side of design studies. There are two types of design study. One is called an evaluation study and one is called an optimization study. And what we're going to be looking at is going to have a quick look at both and then we're going to run through the evaluation study first and then we're going to run through the optimization study. The optimization studies are simulation based, so obviously you need SolidWorks simulation to use them. And the evaluation studies are not. They're just having a look at a variety of possibilities more than anything else. So the first thing is to create a design study. We right click down in the bottom right hand corner and you've got the option create new design study. So we'll click on that. We then need to add some variables in. Now, the variables are listed as parameters. Because I've already been through this bit, we've already got them listed here. But essentially, you click on Add Parameter, you type in the name of the parameter that you want to use, and then you saw me earlier select the dimension. So if I double-click on these, select the dimension that you want to link the parameter to. Once you've created some parameters, you can then add them in. And in this case, I'm going to add in my top width and my top length. And we're going to set values for these between 500 and 1500 and 1000 and 3000. Now, we've got three possible options: range with step, discrete values, and just range. Both range with step and discrete values mean you have to set specific numbers. So in this case, this is 500 to 1500. And going in steps of 500 mil, and I'm going to change that back down to 250, and between 1000 and we want 2000 there, and we're going to do that in steps of 100. Okay, so we're going to do discrete values there. We then need to set up a constraint. Now in this case, the constraints use sensors. These are standard SolidWorks sensors. Again, I've already previously created the mass sensor which we're going to be using. And this mass sensor is a standard, like I said, standard SolidWorks sensor, and I'm going to set that as 90,000 grams, i.e. 90 kilos. The reason this is so heavy is I've got metal legs, and to make the simulation study a bit easier later, this is a metal sheet as a top. So once we've done that, because it's not an optimization study, I'm going to untick the optimization, then choose Run. It's telling me there's 55 active scenarios, so I'm going to click Cancel. And in the options, I can choose fast results. This means there's less, or SolidWorks does more interpolation via calculation rather than putting additional points in. So it makes the number of solutions much quicker, so from 55 down to 10. And then what it does is it buzzes through all of the possible scenarios that it's going to calculate, and you can see the image changing at the top here. And then once it's finished, we get a lovely little noise, which you hopefully can still hear. And what it does is it runs through and gives us all of the items where we've achieved a certain mass. So in this case, our mass, as I've said, the mass was greater than. I meant to put less than, apologies. And all the scenarios where the mass is not greater than 90,000 are listed in red. Now, you'll notice there are some what I would title black columns and some grey columns. The black columns are ones where SolidWorks has explicitly calculated the value. The grey columns are the ones where SolidWorks has interpolated the value between two calculated values. So these ones are, I suppose you could say, accurate, and these ones are estimated. But it then gives you far more results. So what happens is we very quickly got a good look at which of our scenarios weigh more or less than 90 kilos. If I want to explicitly test a scenario which is in grey, we can right click on it and it says it's interpolated. So I right click on it and we choose Run, and then it will explicitly calculate that scenario for me so that I know those results are accurate rather than interpolated and calculated. Just 1 second. So we can then calculate explicit scenarios. So that is very quickly having a look at the evaluation studies. Now I need to set my sizes back, because what happens, you'll notice as I click the various scenarios, the size on screen actually changes. So as I click on it, you'll see the image changing. It is actually physically changing the sizes of my model. Now there are pros and cons to this. One is that it makes it very easy to go, oh, I like the results from that one, I'll take that one, model is updated, we can carry on moving. And you know, it does it all for you. The disadvantages are, if you forget to click on your model, if that makes sense, at the very beginning, then when you go back to your model, it's all changed. So you just need to remember that the scenarios you click on, they are the actual calculated values. So you need to remember to actually select the relevant items. For this reason, SolidWorks actually specifically suggest that you run design studies on non-production data. So you take a copy of your production data, you work with that, be it an optimization study or an evaluation study, and you work with it sort of as a copy, so that you don't accidentally select the wrong scenario, click save, and mess up your production data. So it's just something that they actually advise you do. So I'm going to select that particular study, and I happen to know that I've got the wrong sizes. So I'm just going to very quickly change these in preparation for the next step. So just allow that to rebuild as well. So that was a very quick evaluation study. Now, an evaluation study requires, that was okay. I thought I carelessly clicked on something then. Evaluation study requires some variables to test and some constraints to give you whether it's succeeded or not. What we're now going to have a look at is a new design study. Apologies, no, I don't want that yet. What we're now going to have a look at is an optimization study. Now, the optimization study requires a simulation study to base the data on, to optimize the data from. So we're going to create a new study, a very simple static study that we're going to set up. And this static study, I need some fixtures. So I'm going to create some fixed geometry on the bottom of my model, so the front of the feet of my table. And I also need a load. I'm going to be no more complicated than that. You can see I've previously split the surface here, and we're going to set that to, let's go for 2000. Okay, so we've set up our static study. I'm going to run the static study just very quickly through. So allow that to mesh. It's taking longer than I hoped it would. My computer's obviously having a slow moment. There we go, and just let that solve. Okay, so we've got our study there, and we're just looking at stress results. Obviously, where the weight is, there's far more stress, but you can also see on the legs there's stress concentrations at the corners. Nothing particularly surprising when you look at the model. So we're now going to create a design study. Now this is going to be an optimization design study, and I'm going to need to set up some parameters. I've got my parameters for my top length and my top width, but I don't want those. We're going to go in and create some new ones. So this is the depth of the foot, but for the top section, hence upper. And if I come in and we double click on that leg, I can then choose this value here. And upper leg length is the length of the leg. We're going to choose that value there, and then I'm going to do the same for the lower leg. Okay, and then finally I'm going to use the width of the table again is going to be my last one. So I'm going to say OK to those. So upper leg height, upper leg length, lower leg length, lower leg height, and then I'm actually going to use top width again. So these have all come in default range with step. We're actually going to choose them all as ranges. And I'm going to vary them between 50 and 80 for the heights, and for the upper leg we're going to have 400 to 500, and lower leg we're going to have 400 to 600. The upper leg length is shorter because otherwise it'd stick out and that would look unsightly. And then 50 to 80 again, and then the width we're going to have between 500. Apologies, I've gone and selected the wrong thing for width. Let me get rid of that one. I meant length rather than width. That one, there we go. We want that between 500 and 1100, and again we're going to have that as a range. Now we need to set up some constraints, and this is where the simulation data comes in. So all of this is exactly the same as it was for the evaluation study. We're now going to set up for the constraints, and we're going to add a sensor, and this sensor is going to pull in the simulation data. So because that study exists, I can pull in the stress. We're going to have it in Newton millimeter squared, model max. Now I don't actually get to say what it is in this window, we're just creating that sensor. But because this sensor can pull in the simulation data, obviously the simulation data needs to exist first. And we're going to say that needs to be less than 200. Ooh, less than, I'll actually remember to switch it over this time. Less than. Now this box here is telling you which study it's coming from. You can have multiple studies. And when you've got multiple studies, as in you can have multiple simulation studies. And when you've got multiple simulation studies, you can bring in information from each of those studies. And that means that when it's doing the calculation, it will change the sizes, run the simulation, check against the data, and then if you've got more than one simulation study, it will then run all the other simulation studies for those sets of parameters, and then it will come through and tell you whether you've hit the goal or not. So if I scroll down, we'll then see we've got a goal. Now, goal isn't something we set last time. So this goal, we're actually going to say we're going to use mass because we want the overall mass. And what happens is we're setting a goal to minimize the mass. So the easiest way to reduce the stress in this model would be, I've realized I've not filled in that box. There we go. The easiest way to reduce the stress obviously would make these much bulkier. And potentially much longer as well, so that stress is added over a larger area. But obviously that's going to add more weight. Now, in this particular situation, I want to reduce the weight, and by reducing the weight, it's going to be cheaper to make theoretically. And I have realised I've made a boo-boo, so just let me add a quick parameter here. It's me trying to reuse values that already exist, and I want that one. It's a good job I realised that before we went to the next stage. Okay, so I've got my setup done. We've got a number of parameters which involve the sizes of my legs and the width between the legs, because obviously this was syncing the table, so bringing the legs together should make it stronger. I've then said that I've got a constraint where I want to make sure the stress is below a particular value. And then finally I've got a goal where I want to minimize the mass. And mass is often something you might want to minimize. On the other hand, you could swap those round and say I've got a constraint where the mass cannot go above a particular value, and I want to minimize the stress. Yeah, so your constraints and your goals are often not interchangeable, but often you may swap between the two. depending on what is the important value for your particular situation. And then you click Run. Now, apologies, and then what happens is we click Fast Results in order to get a smaller number of studies. At this point, we'd click Run. Now, in good Blue Peter fashion, I have already done this before. So if I jump in here, allow it to load up, and we'll see all of the results I'd have had for that simulation study and those particular set of variables. So if we have a quick look through, we can see these values are all the same as before. I might have changed the names a little, but they're all exactly the same as they were before, and we've got our results out. So what happens is it's gone through, it calculated the initial sizes and said that although the weight was here, I failed. And as you go along the to the right, you can see all the iterations that are red are failures. So I've obviously was pretty strict on my requirements. All the grey iterations are ones that succeeded. And then what SolidWorks has done at the end is it's taken the values, and because they were listed as ranges, it's then interpolated between the values to come up with what it calls an optimal value. Now, with ranges and taking optimal values, you notice that I've got a leg height of 51.59439 millimeters. Now, this is one reason to use ranges with steps, is you know you're going to get an answer out that represents a manufacturable item. And so you'll get a round number, essentially, as opposed to this where you get very awkward numbers, but it does give you the lowest mass for a stress which is within my 200 categories, or my 200 requirement. So this is where you start to use the simulation studies to give you that extra information, those extra tests, where you can optimize the value based on having some additional data to compare to. Now, I've got one other, let me get rid of that message, it's complaining that GoToWebinar is open. So I've got one more file which we want to have a quick look at. This is, I'm just going to actually allow the simulation study to run on this one. So again, I've got a static file, it's just adding the load. We can also add an additional study, so I'm going to do that very quickly. So we're going to add a new study, we're going to add this one as frequency, and allow that to calculate, and we're going to use the same geometry as before. So my two studies are based on the same information. Obviously, if I had two studies that were based on different information, that's why I'm going to need to make that 1,000. It would make life a little bit more confusing, I suppose, more than anything else, because you're trying to get results from tests which are testing different items. So now we've got two studies done. Let's just run that very quickly. Apologies, I forgot to change my settings. I need the direct sparse solver in order to run frequency studies. Now, in this case, frequency studies are part of Simulation Professional, so I'm just showing you them so we can have different studies. If you're just using static studies, Simulation as SolidWorks Premium would be absolutely suitable. If you're just doing design studies without optimization, then obviously you don't need the simulation elements. So just allow that to solve. And it's just solving for the first 5 natural frequencies of this item. There we go. So we've got our results for the first 5 natural frequencies, and this then means that when I come to doing the design study, Again, we're going to run an optimization study. We can add in a number of parameters. So we might add in length, and we might link that to here. We might run in height and link that to this one. And then we could start running our parameters for the thicknesses of the various bits of material. So I'm just going to select one, and the reason I'm just going to select the one rather than go for all of the gaps is it reduces the number of simulation steps it has to do, makes life a little bit easier for everybody, slightly more interesting to watch. So I've got my values, and what I'm going to do is we're going to have the length between 150 and 200, the height between 100 and 200, and apologies, that should be 250, and then we're going to have this between 10 and 50. So essentially this is the item we're trying to change most. We can then add a sensor again, so you can see this is all starting to be very similar. Again, we're going to use simulation data. We're going to use stress to begin with, and we're going to ask for the stress to be less than 25. This is an aluminium part, which is why that's so low. And then we can add another sensor, and this time we could actually look for the frequency value, and we could say we want to look for a frequency value for the model max at a specific mode shape. So I could say that at let's say step 4, because I know I've got that one solved. What I want is I want that to be less than, let's say, 1600. So if this was a desk bracket or wall bracket and you've got computer equipment on it, for example, you've got a whole lot of fans and things that will be spinning at that speed. I happen to know, because I previously checked the results, that your mode shape between 4 and 5, 1600 is between 4 and 5. Hence why I picked my frequency of step 4 to be between those two. And once we've added those in, we need a goal. Now, as with all of my goals, I've been very dull, I have to confess with this. We're going to be trying to minimize mass. You could also try to minimize volume, although for a single material, that's going to be exactly the same test. So we've set up our design study. I need to make sure I remember to seek fast results to reduce the number of tests it's going to do. We want it to optimize, and then we can click run. Now it's doing 15 tests because I've got 3 items. If you've got 4 or 5 items, 6 items, 7 items as your parameters, your variables, then that number goes up each time. So what happens is for the studies, I'm hoping it's not going to take too long to process these. I might have to stop them, unfortunately. So hoping to let this run through. For the studies, what happens is it will set the values, as I said. It will then mesh and solve the static study. It will then mesh and solve the frequency study, and it will then input the results into the results view. It will then come to the next set of values. It will repeat the same. So it repeats for each one. So the more items you have, the more constraints you have, the more goals you're trying to achieve, the longer the process takes. And I was hoping this wasn't going to take too long, but my computer is not having a good morning. I was hoping to let that solve. Apologies, I might have to skip this because it's going to take a very long time. Right, while this is going on, I'm going to summarize what I talked about. We'll carry on with the rest of the webinar, and with a bit of luck, although looking at how long that's taking, we might get some answers by the end of it. So, design studies. There are 2 types of design studies. You have evaluation studies and you have optimization studies. Evaluation studies allow you to put in discrete test points for SolidWorks to check. It will then interpolate between those test points to give you a large number of results for your different parameters, and it will tell you whether things achieve or fail a particular constraint. So the one I used earlier, we had a constraint over mass. They don't require any form of simulation. The optimization studies tend to be used with the simulation results, and what happens is they allow you to put in a series of information. Doesn't have to be discrete steps for optimization studies, and then it will take your parameter values over a number of iterations, and it will rerun the simulation studies for each of those, assume you've got them listed as constraint, and then it will give you a goal as an output. So whether you achieve that goal or which particular part of that goal you're trying to get closest to. So not only will it tell you whether you passed or failed on constraints, but it will also tell you whether you achieved or whether you minimized or maximized a particular mass or stress value, for example. So those are the two major parts of design studies. How do we get to design studies? Well, we go down, we right-click on the labels at the bottom, and we say, give me a new design study. The steps we follow: we create a number of parameters. We then set the boundaries and the step sizes for those parameters. We then set up sensors to run our constraints. And if we're doing an optimization study, we also set up a sensor to run as our goal as well. So we get those items out. It then gives us a results view where we can have a look at whether something passes or fails our particular constraints. So here you can see it's passing the frequency constraint, but it's failing the stress constraint. And it will give us what the goal is at that step. And then once it's finished solving all of our iterations, it will pick the values that get us the best result on our goal, which is the last row, while passing both our stress and our frequency test in the constraints area. So this, unfortunately, it's not gonna finish, which is a real shame because I'd like to have shown you those results. I tell you what, it was a lot quicker than I was testing yesterday. So in the meantime, let's go back and have a quick look at some upcoming webinars. So next week we've got using advanced sheet metal functionality. So we've previously done a webinar using some sort of basic sheet metal, showing some of the basic features. This is going to have a look at some of the more advanced features, the features we find that people use less often, but that we still think are pretty useful. The week after, we've got a segment on enterprise PDM tasks and creating PDFs automatically with your workflows. So if you're an enterprise customer, feel free to come and have a look at that. On the 11th of July, we've then got some 2D to 3D migration tools. So this is importing 2D data and making 3D models out of it. As always, if you've got any questions about this webinar, if you want me to send you the file with the results in it, for example, then feel free to give us an email, give us a ring on the number below, and any support questions at all, feel free to get in contact with us. Right, let's jump back into SolidWorks. No, we've only got as far as step 4 of 15. So I apologise for that. I apologise for the problems with the audio at the beginning, but it looks like we've got there finally. I suppose the last thing is, are there any questions before we go? Right, guys, there aren't any questions at this point in time. As always, there will be a video of this up, and I will make sure that video has been trimmed of the bit where I was silent. So it's nice to have seen you guys, and talk to you again soon.